Okay, the existence of a limit. Very first question asks us to evaluate the limit of x as it approaches 3 from the left. Okay, and what we have here is a root of 9 subtract x squared. Okay, so what we're going to do here is we're kind of looking at, if you were to graph this, you're looking at a circle function. Okay, if you're not going to graph it, you're going to think about the numbers. Think about whole numbers when coming at this. Okay, I'll quickly draw the graph, and then we can think about it algebraically with our numbers. So if we were to graph this, it's something that looks, here's our graph. And what we have is essentially a semicircle when going through this. Do I have a circle function? Yeah, I do. Okay, our semicircle looks like, looks like that. Okay, this is what the function looks like if it was graphed. We have our root of 9 minus x squared. Okay, so this is our function if graphed. Now, algebraically, let's think about this. Again, they're asking us to approach 3 from the left. When x approaches 3 from the left, and we have 9 minus x squared. Okay, if we're approaching from the left of 3, that means we're using numbers like 2. Okay, and this is the 3 we're talking about. Little numbers like 2. Well, if I have the number 2 in here, we know that the number 2 in here squared is 4. 9 minus 4 gives us 5. We're looking for root 5. So this exists, right? And we can keep going back, and the graph will really help us in this case. Because once we get to a certain point, okay, so we had the number 2, 0. 0 squared is 0. Root of 9, well, that's here at 3. So when x is 0, we know our y value is 3. And then the graph starts coming down again. Think of, again, the number, let's say 1, negative 1. Well, that becomes 9. Subtract negative 1 squared. That gives us positive 1. 1 subtract 9 subtract 1. We're looking at root 8, something over here. Now we're going to get very close to this. In fact, we're going to get to negative 3. 9 subtract negative 3 squared. Well, negative 3 squared is 9. So we're left with 9 subtract 9 is 0. Okay. So 9 subtract 9 is 0. Root of 0 is 0. Okay. But that's way back here at negative 3. The question's asking us about 3. So as we approach 3 and we get to the number 3, let's talk about this limit here. When we're coming at it from the left, well, we know we're getting to what number? And we're going to plug in 3 from the left. So we'll plug that number in, 3. And we're going to get root 9 subtract 3 squared is going to give us root 9 minus 9, which is essentially the root of 0. So we get 0. So when we approach 3 from the left, the limit of this function, so the limit of x as it approaches 3 from the left, and we're talking about the limit of root 9 minus x squared is equal to 0. We're essentially hitting the number 0, and we plugged it in algebraically. We still got the number 0. Okay. Now, the second part of this question. So we're able to find it approaching it from the left. Why can't x approach when x approaches 3 from the right be determined? Well, remember, we're not actually at the number 3. We're a little bit larger. So let's jump up one number and say that it's the number 4. Okay, so this will be our b. We'll do it in red. Part B. Algebraically, let's think about this. X minus, if we had the number 4, 4 is technically to the right of 3. 4 squared would be 16. 9 minus 16 gives us the root of negative 7. Can I find the root of negative 7? I can't find the square root of a negative number because there are no two terms multiplied by themselves that give us a negative number. Right? Negative 2 by negative 2 gives us positive 4, and positive 2 by positive 2 gives us positive 4. So no matter what we multiply by itself, we always end up with a positive number. This is indeterminable. We are unable to find that. So what that means is anything greater than 3 coming at it from the right is indeterminable. We cannot find the limit of x as it approaches 3 from the right. Okay? So this, if they had written it this way, limit of x as it approaches 3 from the right, and that's the limit of 9 minus x squared. We cannot determine this, okay? So it's not defined. And then it talks about the existence of this limit. Does this limit exist? Okay. Now, this limit doesn't exist because if we're approaching it from the left and the right, we're not able to find a limit. We are able to find it if we approach it from the left, but because nothing approaches it from the right, this limit does not exist. But just like in the other question where we had two different numbers, where we had a piecewise function that ended at 2, and then it was continuous again at a higher value of y, because our limits approaching from the left and right are different, that limit would not exist either. Okay? So these are reasons why a limit would not exist in a question. In fact, let's see if we can bring both of them up. Okay? These two questions, both of them deal with limits that do not exist. One because it's not the same when approaching it from both sides, and the other one because one of the sides does not exist. Okay? So these are limits that do not exist.